is actually done these days. So what I'm going to do is we're going to go to Excel, one of my favorite tools. So what I'm going to do right here, friends, is we're going to look at a coin being flipped over and over and over again. And when I say being flipped over and over and over again, I'm using a command to do this. We're going to use this command in your TIs today. There's a command in your TIs called randint. TIs is called rand between. And what it does is, it flips a coin, and the coin has either a 1 or a 2 on it. If it comes up 1, we're going to call that heads. And if it comes up 2, we're going to call that tails. What this is doing is it's taking Christina's model and making it digital. So instead of the coin going heads, tails, it's going to go 1, 2. Fair enough so far? Hopefully, fair enough so far. Good. So this is going to graph the probability of heads. So when I press F9, it just flipped it, and it came up tails again. So right now, I flipped the coin twice and gotten tails twice, which means the chance of heads, by your neighbor's definition, is 0. It has to be, right? Because by their definition of heads and tails, you have to flip it in order for it to register as a probability, and since you burn the heads, they're going to get the tails next time. Now, we all know that that's a little bit overly simplistic, but by this definition, the chance of heads is still 0. I'm going to flip it again. Now, I have flipped it 3 times, and now I've flipped it 4 times, and look what's happening as I keep track of the heads and tails. What is happening to those probabilities, friends?
It's getting closer to 50%.
Oh, it just froze. Uh-oh.
Oh.
Oh, there it goes. Hold it down. Where's my stapler? Here it is. Hang on. Now let's see if I have the thing set up. I think I should do... Ah! That's what we're... Now look what's happening. Okay. It's going to go... Okay. Hang on. Let me set it up. I thought I had done this already. Let me set it up so that it just auto goes. Uh-oh. Oh, goodness. Oh, goodness.
Broken.
No, this is a new version of Excel. I forget how to do this.
Oh.
I want to just go... Oh, I know how to do it. Hang on. Let's just make this 1500. There we go. There we go. Is that good? Do I just close it now? Okay, there we go. Let him just go ahead and keep on marching. So you said, Josh, please!
Is our exam and the projects that we're going to be doing regarding...
Similar to this.
Is that going to be off of the old Excel or the new Excel?
Oh, it doesn't matter, because you won't have to change what I just did.
Okay.
All you're going to do is run the simulation like I'm doing here, which involves the F9 button.
Gotcha.
Yeah, you don't have to actually create... Your project for next week involves making graphs in Excel, which might look slightly different than... But what I just did was getting into the guts of the graph, which you don't have to do.
Okay.
Okay. And don't forget that if you get stuck doing something in Excel, like for that project next week, you can always Google the result. I mean, or send me an email with your chart attached. Microsoft pisses me off because they constantly release new products that fix problems that weren't problems in the first place. Right? They made, this is Excel 2000, whatever this is, 2014. Excel 2010 was fine, but they made a new version, just like Apple does, just like every tech company does, to make you buy new stuff. Now, I asked the IT department recently, why do you buy new stuff? Just keep using the old one. And Microsoft is genius. You know why we have to keep buying new stuff? Because they won't support the old stuff. Which means if something goes wrong, they won't fix it anymore.
Oh, that's
so
ridiculous.
it's ridiculous, but we keep buying their stuff.
Right.
So until we go open source, which we should do, which we haven't done yet, it's going to continue. So but don't forget that Google, that's why Google Forms are so wonderful. Google Forms are wonderful because of that result. Okay, we're off the chart again, but that's okay. Notice the probabilities. 49 to 51, they're getting a little bit stuck there. But don't worry, as this thing goes on and on and on, what are they going to even out to, just like we saw in class before?
50-50.
Good. So, what does the 50-50 mean in a different way? I'm going to blank this out and go back over here. What does the 50-50 mean said a different way? More. Yes, 1 for every 2, but more. Give me more than that. Because 1 for every 2 would mean your neighbor was correct. You got heads, he gets tails.
But if you use randomness, 1 for every 2, then it's okay.
How is it okay?
Because it'll like,
Because right now your neighbor thinks he's right.
every time...
As a matter of fact, he's already brought the stuff over to your house to sharpen the blades because he's convinced he's not going to get heads because you did.
Every time you re-flip, you're re-randomizing.
Yes.
You like my terminology there?
I like it very much, actually.
Made
Here,
sense.
And then, so, from every time you flip, then you have the 50-50. You just have to start over and make them realize that.
Okay. I like this. Okay. I like the starting over bit, right? But your neighbor can't get past the first thing you said, which was brilliant, by the way. 1 for every 2. He's like, I heard you say that, actually. You said 1 for every 2. And you flipped heads, that means I'm going to flip tails. Then you say, no, you gotta start over. You're like, why do I have to start over right now? Why do I have to start over right now? You flipped heads, that counts. Because your neighbor's kind of angry, it's a pain in the ass.
Because you already used the 2.
Right, because you already used the head, it means you now have to get tails because the heads has been used.
But you still have the same
You still
coin,
have the head
and
and
it
the
still
tail.
has a head, and it still has a tail.
Don't get too far from what Ashley said. I love what she said. 1 for every 2. How does that work? What does the 1 for every 2 mean? This is correct. On average, over a long period of time. Well, it's exactly 1/2, actually, but roughly in a short period. But over a long period of time, it means for every head you flip, you will also flip a tail. It just doesn't guarantee when that's going to happen. That's what people don't understand. That's the part. Your 1 for every 2 was great. Your 1 for every 2 was great. What the 1/2 can also mean, simply though, is it's the number of times heads is flipped. This is the part people have a hard time with. It's the number of times heads is flipped divided by the number of times the coin is flipped. Now notice, nowhere in there is there an ordering mentioned. It doesn't say you go heads, then tails, then heads, then tails. Because that's not what 1/2 means. As a matter of fact, if that was happening, I'd say somebody was fixing something. It's too neat. What it does mean, though, is it's possible to take the big chunk of heads and tails in a row and rearrange them so that they are heads, tails, heads, tails, heads, tails. But they're not going to occur like that. So when you see 1 for every 2, which I love that, by the way, the 1 for every 2, that's just a perfect way of saying it, actually. It's just not a guarantee of the order of when things come. That's what people have a hard time with. Gesundheit. You've often heard the table is hot. The dice are due. That's Gesundheit. That proves people don't understand probability. Because those terms don't exist except in people's minds. Nothing is due. If you say the dice are due, that implies the dice remember what just happened and have burned some outcomes and then can't burn them again. That doesn't make any sense, right? Now, what people are thinking like, and this happens to me all the time, when I got this friggin' rack of keys that I haul around everywhere to open the damn doors. I put the green sticker on there finally, which made me remember that's the key that opens this door. But before the sticker's on there, I just grab a key and try the door. And it doesn't work. That means I'm more like, assuming I'm not an idiot, that's a dangerous assumption. Assuming I'm not an idiot, I'm going to be more likely to get it on the next key. Because if I'm smart, I won't try that key again. See, right now I've got 6 keys. It's basically rolling a die at this point. I got 6 keys on my ring, right? I try one, and that doesn't work. I put it over here, and I don't try it again. Now I got a 1 in 5 shot of getting the key right, which is better than 1 in 6. But dice don't work like that. Dice don't go, what did you just roll, Josh? Just out of curiosity.
I rolled a 6.
He rolled a 6. He can roll a 6 again, can he? It's funny you mentioned that. Was it in this class where I rolled 2 6s last week?
Yep.
I did that. I did the exact same thing. I threw a 6, and then I threw a second 6. It's not hugely likely that that happens, but it's possible. And that's the thing. People forget the possibilities. Once they see something go by, they assume it can't happen again. Hell yeah, it can, if it's equally likely. If it's equally likely. My grandpa, rest his soul, used to always bet 701. There's a play 3 game in Delaware. 701. You always bet play 3, 701. I said, Grandpa, why do you do that? He's like, well, I figure if I play it every day, I'll win eventually. I'm like, yeah, but you're just as likely to, if you change the number every day, you're going to win eventually. I don't believe that. But it's true. There's one number that will win every day. What's the chance at 701?
Well, 1 out of however many.
1 out of 1,000. And the reason it's 1 out of 1,000, this might be a little bit tricky. We can go back to this one if you want. It's 1 in 1,000 because there are 10 choices for each of the 3 digits, 0 through 9. So it could go 0, 0, 0, 0, 0, 1, 0, 0, 2. If you use your last project, use your last project to think about it. The first branch has 10 branches. The first branch has 10 possibilities. Each of those has 10 more, and each of those has 10 more, and it gets exponential. 10 times 10 times 10 is 1,000. So the chance of it being 701 is 1 in 1,000. Christina, give me a 3-digit number. Anyone?
3-digit number?
3-digit number.
333.
What's the chance of being 333?
1 in 1,000.
1 in 1,000. 1, 2, 3.
1 in
1 in
1,000.
1,000. 0, 0, 0. Always wanted 1,000. So you see, if he just simply took, you know, a 10-sided die and rolled it 3 times and had that decide what number it was going to be, that's just as likely as using the same number every day. But for some reason, our human minds think that if I play 701 today and it doesn't come up, that it's due to come up more the next day, just like, I like when you said gone, Josh, that's correct, isn't it? No, it's like this, right? Here's my grandpa playing 701 today. What doesn't fit in the door? I'm not going to play it, or he's going to play it again. Now, these are the remainders, right? If it didn't come up on this key, it's more likely to come up on this key. Well, that's ridiculous. The number comes up because it's painted on little tiny ping pong balls, getting with the hairdryer, and it pops up the top. It's not remembering anything. It's not like they took the number out and then put other numbers in.
Right.
Right? If they did, oh my God, the lottery wouldn't work. They'd have to change the payout or change the cost.
Oh, yeah.
But that's what people suck at. And it's part of being human. I mean, being random does not jive well with survival. Think about it this way. People that act purely randomly, their genes are gone because they're dead. Right? What do I feel like doing today? I feel like walking off this cliff. That's a random thought. And now your genes are gone. It's natural selection. Randomness does not make a good gene pool to continue breeding from. Brittany!
So, does that mean if you go buy a Powerball ticket, you're better off letting the computer randomize the numbers for you?
It's not that you're better off, it's there's no difference. So if you have like a favorite number you want to play, go for it. But letting the computer randomize it, you're just as likely to win with Powerball too. Absolutely, sister. Good for you. There's another hand went up. Anya, was that you?
Oh, I was just going to say, yeah, but isn't the order of nature entropy? Isn't entropy randomness?
I don't think so. I don't think so. Here's why. Here's why. Things do seemingly happen randomly, but don't confuse butterfly effects with pure randomness. Right? For example, birds that have those crazy little beaks.
Crossbills?
Crossbills, right? They develop those beaks because they open certain seeds. Right? There's a certain nut that they open with that bill. How the hell does that happen? Well, first of all, we got to remember that it takes millions of years to evolve into that.
Yeah.
Right. So how does that happen? It happens slowly over time. So here's the deal. That crossbill was probably at one point a genetic defect. I'm guessing. It was some random defect. And here comes this poor crossbilled bird. Now, you got to realize, just like the infinite monkeys theorem, that crossbill probably happens in lots of other bird species that are born into places without that special kind of seed. So in other words, a crossbill born in a place without crossbill seeds is going to die way more quickly than a non-crossbill bird without that seed. Does that make sense right now? Hopefully that you buy that. Okay.
Advantageous.
It's not advantageous unless you have the seed that actually mixes it. But then, we roll the die 10 times in a row and we get 10 sixes. That's the nature equivalent of that crossbill being born into a biosphere that has that seed. And that crossbill does a little tiny bit better. And it passes its genes on, because it doesn't die. It actually eats better than the other birds that can't crack that nut open. And it passes its genes on. And maybe even then it doesn't get a huge genetic advantage, but generations go by, and slowly it begins to win. So what's good for the individual isn't always good for the, what's good for the species isn't always good for the individual. But in that one, we rolled a 6 10 times in a row species where it gets dropped on the Galapagos Islands, where there's that particular seed that it needs to open. See, that's the idea. We have no concept of that because it happens so slowly over millions of years. Look at the human body right now. I can name 5 parts of the human body that are stupid. Knees. Please. Seriously? Knees? Give me a better joint, Mother Nature. She is. She is in the process of it right now, but it's happening so slowly we can't see it.
Yeah.
Elbows. Really? They're dodgy as hell. Pregnancy. Childbirth. Not pregnancy. Childbirth. Get her a zipper. My God! Seriously? I'm sure Mother Nature can figure out a zipper mechanism here. I mean, seriously. But we gotta give her time. We're gonna be dead and gone before we see that already. Does that make sense, Anya? I love what you're saying, and I think about this all the time because evolution is due to this. But it's just that it's so slow and so imperceptible. That's why I always laugh when I talk to someone who doesn't believe in evolution. I'm like, explain that crossbill.
Yeah.
You can't explain that unless you believe in evolution, because that's the only thing that makes sense. Why would it? I mean, for some reason, a platypus was created, or a platypus became a platypus. I have no idea why. It's a friggin' thing with a duck bill and a beaver body that lays eggs. It's adorable, and that makes sense somehow. Because that particular gene, which I can only imagine was some kind of a crazy genetic defect at some point, caught on in, where are they from? I'm gonna say Australia, that's why not. Caught on in some part of Australia where it made sense. There is a certain kind of moss that only grows in the entire world. Have you ever seen, what's it called, down by Cay Falls? There's a tabletop mesa or something like that.
Blue green algae, is that what you're thinking?
No, it's a moss. I can't remember what it's called now. There's a flat rock area down by Cay Falls. It's like table rock. It's called Table Rock. There's a moss that only grows on that rock. Nowhere else in the world, just that rock. Why? It probably tried to grow elsewhere. I mean, moss lets out spores. I'm sure the spores tried to go elsewhere, and they plant themselves elsewhere and they die out because it doesn't work. But for some reason, it caught on there, right? And God knows, maybe some other flat rock will appear somewhere else and it'll land there in 10,000 years. But that's this slowly kind of working. Totally rad.
That's why I love science.
Say that again?
That's why I love science.
Science is rad, but
Biology,
science
whatever.
ignoring this is silly.
Yeah.
And that's why science doesn't ignore this.
Right.
Right, you can do all things from genetics down to evolution, all by looking at probabilities.
Exactly.
And the thing about probabilities that I love, though, is this model, the empirical model. Because you can't use die rolls, usually, in natural models. Now, sometimes you can. I think when you're looking at very basic genetics, like what's the chance two brown-eyed people have a blue-eyed baby?
Yeah.
I think it's roughly 25%. I think. And the reason is it 25%? I'm saying that correctly?
Blue eye can't have a brown eye.
Correct.
One of those
Two blue eyes can't have a brown eye, but a blue eye and a brown eye can.
Yeah.
And the reason, it's coin flips.
Yeah.
Let's change the model. Let's change the model and look at genetics. It's a coin flip, okay? So we got time. Yeah, we'll get to the dice, I promise. But the blue eye, brown eye thing.